Hello? Hi, did you go to the party yesterday? Was it amazing? I cannot hear a thing, so probably it was. So, well, Golang, language, well, I would really encourage you to try in 2014, ideally in 2013, but since, well, we can't anymore, you have to do it now. Has anybody been writing in Go? I can see 2 hands and a blinding light. Guys, I really hope that you will give Go a try after my talk. This is not going to be a Go introduction. It's not about all the features of Go or all the language constructs. I will show you some things that I like about Go. I will show you some of the basic stuff, telling you why I like them or why I dislike them. There will be live code, uncommenting, compiling, and examining the runtime. There will be, I will not try to code because that's, well, too brave. So, my name is Andrzej Grzesik. I work in eBay. I'm usually spending my life in London right now. I have a Twitter, an email, and a blog, but it's not very active, but it's there. Things I'm proud of. First of all, a conference called GeekOn that, well, many of you have heard of already. I also organize the Polish Java user group. I also, well, created and organized Kraków Hadoop user group and Software Craftsmanship Kraków. And, well, who am I? I'm not an admin that turned dev. I'm the other way around. I started developing software when, well, long time ago. I started with C, C++, well, actually started with Pascal. Then went C, C++, then got kind of tired of all the mess that C exposes you to, went, well, to the Java side of things, then got irritated with all the Springs and XMLs and containers and things, and, well, saw a bit of Ruby, saw a bit of other things, and now I just try to experiment with what seems nice and what gives me fun. Go certainly gives me fun. A few disclaimers. Well, my opinions are my own. I'm not representing any organization, so whatever I say, it's my opinion. Bash me, don't bash companies or organizations, logos I used. And sometimes I say I hate computers. So just be careful, it's normal. It's not that I'm angry, I just do. If you have any questions, raise your hand, shout. I will probably not see you, but hopefully somebody will be able to give you a microphone. Or if I hear you shouting, I'll try to, well, stop and repeat the question and answer. So, Golang. The first very important thing, if you're looking for Go online, if you type Go into Google, you will find nothing or you will find everything. Correct keyword to use is Golang. Go sounds nicer, but you have to do it, well, this way. Golang is very strongly connected with Gophers. That's the mascot. You can buy it. You can, well, have pictures. There is no other significant thing that is called Gopher in Go. It's just a mascot. It's free. It's open source. It's BSD licensed. It comes from the big G. And it's very fast. If you have been writing in C in any project of, well, a respectable size, you probably know that the compilation phase can take time, well, a lot of time. Go is much smarter in how it processes, well, files and packages, which makes it not go after each header many times. It just processes each package once, which means it's much faster. It's a lot of time saved. Same goes for runtime. It's a native runtime, so it's fast. There is no JVM or any other VM, well, no this kind of a VM being involved. It has a garbage collector, but it's not really scary. And it works, and I personally don't mind having a garbage collector. It's one less thing to have to worry about. Of course, if you want to have a memory leak in a garbage collected runtime, you still can do it. That doesn't give you magic safety. A too long and didn't read or didn't really sleep or partied all night version. Go, to me, looks like a mixture of C++ and Ruby. Guys, come in. There is a lot of space still in the room, so feel free. Syntax is a mixture of C++ and Ruby. Joy is probably the best of both worlds. I hope that you give it a try at least tonight. The first samples that you can go after are really short. You can do them in your browser. Everything is on golang.org, so just give it a go or a spin. So why do I like Go? Well, First of all, there are no runtime dependencies. You just do Go, you have the binary, and then you run it. If you have ever installed JVM on any decent box, you know how many megabytes it weighs, you know how much dependencies you need. It's a nightmare. To download 100-something megs for the JDK over a slow connection is a pain. With Go, you get the runtime because it's statically linked, it's all there, and you just run it. You don't have to worry about things, it works. It's much more pleasant than C. If you have been writing C before, there are certain quirks like memory management, like awkward syntax, or, well, maybe not awkward, certain design decisions that they took long time ago, that now, well, you know that you can do better. Luckily, computer science in some bits at least, well, at least the pleasant bits have moved on a bit. So it's, to me, it is much more pleasant and much more, if I would have to code something that does, well, system level things, I would try to use Go. And an awesome thing, because we all love Maven or we all love Ruby, well, whatever tools do you use, whatever language toolchain that you have, Go comes with one. So if you want to do things with Go, you download the runtime, you get a command Go, and then you can clean, you can build, you can get your dependencies, you can format your code. That's kind of amazing, and that's very important because that means that you don't have to worry about things and you don't have to waste time setting your system up. So the Go command. Don't trust me. Well, trust by verify. So if you run Go in your console, you get all those features. My favorite, well, at first is this one, because this means that there is one format already that everybody in Go uses, which means that the discussion whether you should open the brace in the next line or the end of the current line, or whether your tabs should be 3 or 4 spaces, well, your discussions will be invalid. They will not have a place to happen because there is already one big format that everybody uses because it's well built into the language. So to me, that's, well, in the beginning, really awesome. Also, people can take any code from the internet and you can read it because everybody writes it the same. There are no funny things, funny formattings. It saves a lot of time when you're entering the ecosystem. That's a mandatory Hello World program. What do we have here? First of all, you can see the package statement. Package, if you've done, well, Java, if you've done C++, then you probably have an intuition about what a package is. As I said, if you depend on another package, Go will not compile or process the files many times. It will build each package once. Then in the second line, you can see an import FMT. That's importing another package, which then allows you to use, well, functions from that very package. And then a main, like you would expect everywhere, and the println, well, very self-explanatory. So let's try to do it. And of course, I have code snippets prepared because I'm, well, either lazy or try to be prepared. So, well, that seems to be the basic version of what we need. Yay, we got a hello world. It's working. So now comes, well, I can show you one interesting feature about Go. If I would like to import another package because I know that I will need it in the future and I just need to commit it and we'll use it in a month or so, then, sorry, if you're trying to do things, well, put things into the code that you're not using, Go will complain. It is tiring when you're experimenting. Well, you start to comment things a lot, but in the long run, it pays off. Because your code is free of any garbage that you would normally write or put into your source code. You don't have things that are not used, which means, well, you create less code, it's less to write, less to maintain, well, generally less messy. And I'm saying, well, I'm making assumptions that it works. Actually, we've used Go in production. We had a classic Java, well, Java Spring Tomcat-based application, and then we decided to rewrite it in Go. And the awesome thing was, while the Java app was a few thousand lines of, well, Java's, well, XML and all the boring things, plus you had to have Tomcat or any other web container. When we rewrote that into Go, we got more or less an eighth of the code. And yeah, 1/8, which is, wow, amazing. And all the features that we had in the Java app were there, which was, well, to us, it was mind-blowing at first. And it didn't fail. It was easy to read. It was much faster to read because, well, you just spent an eighth of the time reading. And the syntax, to me, is, well, pretty readable. There are no magic symbols like, for example, Scala might give you. So it's pretty straightforward. So let's start with a few basics. Types. So in terms of variables, well, they can have types. Those are the things available. You have unsigned and signed integers, you have floats, you have complex numbers, you have a byte, you have a rune, you have a string. String is a type, it's not a class, which means if you want to check the length, you will have to do len of, well, your string variable. There is also an int without, well, the precision predefined, but that's platform specific. But what I actually like about this very much, you can be explicit about how many bytes do you need in your int or float, well, something to be. So if you have an unsigned int of 32 bytes, sorry, 32 bits, you know what's there. No, well, end of discussion. There are no assumptions. Well, I get an overflow. Well, if you have chosen this type, you probably already knew what you were doing. So the expressiveness of the language helps you. Byte rune, well, I think I might have missed a boolean, but still, you see what happens. A sample program, you can declare a variable and assign to it, or you can declare and assign it in a single statement. That's why that's why this happens like that. And as I said, if you want to check length of your string, it will not be your text.length. Sorry, that's len. Well, just a convention. To me, it seemed awkward at first because I spent a bit more time in object-oriented languages, but later stopped hurting. Well, it's just the way things are. You can also do maps or well, dictionaries or whatever you call them. That's what the API looks like. Quite straightforward. A map from with a key of this type and an entry of this type. Straightforward, easy to, well, read, I think, easy to initialize. Funny bit, you can have a comma at the last entry, so if you want to shuffle your lines afterwards, you can do it easily. If you want to add yet another thing, you can do it easily and keep shuffling, and it's there. It will. You don't have to remove or add commas depending on the position of the values. That's what I like about it. But as I said, those are, well, my preferences. And an interesting behavior that we get in here, if you try to print something that doesn't exist in the map, in here we get a false. And that is because for a Boolean, the zero equivalent value for this would be a false. For an integer or for a float, it would be a 0, and so on and so on. For a bigger construct, it would be a nil. I like it because, well, in some languages you might get undefined things. In here you get, well, the defined 0. So kind of falsy. Well, it's not really falsy, but it's, well, the behavior is at least consistent. Structs, because as I said, well, close to C, so structs seem to be in place. This is what a struct looks like. You declare the fields, then you can, well, create it either explicitly following the order, or you can specify which parameter you want to assign what value to, which also means that you can shift them, and Go will, well, figure it out, which is very, very nice and very useful. But I'm very happy that this form exists because I find it really readable, especially for structs that are a bit more complex than a rectangle. And, well, there is something that's made its way from the next slide, so let's move on. If I would like to have a function on a type. How can I do it? It's quite easy. You just declare a function that accepts this struct as a parameter. And as you can see, functions in Go start with a capital letter. Sorry, well, if you're on the .NET side of things, well, you're used to it. If you're on the Java, that's a new thing, and that's how they do things. Return value, and, well, self-explanatory, I think. So after something like this is defined, well, you can just call s.area or square.area, and that will obviously invoke what you expect. So moving on, interfaces. If I want to have an interface, and it's not, how interfaces work in Go is a bit more, well, interesting than in for example, C. It's not a, you don't go after your inheritance chain. It just doesn't has its place there. I can say that a square implements the has area interface just because the method signature that this interface has here is present, well, for this type. So this signature, so as you can see, an area func that returns an int needs to be, well, it's in the interface, it's in the type. So I can, I can cast and then call area and treat square as an object that as something that has area. That's simple and that's very powerful because it means that you don't have to follow complex inheritance chains. If you just declare the right methods, you can treat your object as of something, or you can. I find it really useful, especially when dealing with I/O. If you want to write a custom I/O wrapper, it's very easy and it's very fast because of, well, how little code you have to write. Goroutines. So you've noticed the word func, or well, which stand for functions, and if you've heard of Go, you probably have heard of goroutines, which are lightweight threads. So they are not behind each goroutine there isn't a thread all the time, so you can create as many goroutines as you wish. What is a goroutine? Well, a goroutine essentially is it's a function. So you can treat it as a function, so you can just call it, or you can treat it as a goroutine and launch it as on a different thread, like by using the word Go. This means that this will happen independently of the execution of this function. But, well, I can tell you a lot of things and tell you that, well, the roses are usually blue, but maybe let's have a look. So, yeah. Now we probably need this, we probably need this. Let's see what happens. Undefined time, so I actually need it. So yeah, and it waits for something. So what happened in this bit of code? Well, this time we got the order correct. This time we also got the order correct. What happens? This bit means that we are invoking a goroutine with a parameter, and if there is a thread available to pick it up, it will be picked up. You can see this funny runtime.go max procs. Looks big enough, which means that which means there is an assumption in Go that you can either set the number of simultaneously running functions either by a environment variable or using this Go runtime. If you don't, then the number is 1, which means all the concurrency will be, well, pretty limited. It will just not happen. If you do, you can have many things running in behind and they are independent. So let's go back to our presentation. So how many will run? That's why I did the runtime go max procs, to actually make them all available to be run together. Of course, if you have less cores than you enable this for, then it doesn't really make sense because your threads will have to be, well, migrated or evicted, and it's a lot of performance wasted. So it usually makes sense to get the number of processors or cores that you have in your system and then use it as an argument and do it in runtime, because it might vary from a machine to machine. And if you have different functions, you probably, goroutines, you probably want them to communicate somehow. That's what channels are for. Channels is, a very interesting construct that exists essentially to communicate between functions. It is typed, so it is, if you know the type, you're safe. And it's thread safe, so you don't have to worry about doing synchronization primitives, barriers, mutexes, what have you, whatever you would prefer on your own. It's done for you. Just use the channel, it will behave correctly, and channels are part of the runtime, which is pretty awesome. This is how you make a channel. You specify, well, you invoke make, tell it to create a channel and the type. You can use a struct here as well, and there are two kinds of channels. The form that you have seen just before is an unbuffered channel, so it doesn't have the size specified. It works in a synchronous manner and will wait when empty when you try to read from it, which has its uses, but we'll get there in a bit. And you can also make buffered channels, so channels that have a size specified, which means a continuous chunk of memory will be allocated, and it means that if you try to, well, first of all, they are asynchronous. They will return, well, the 0 elements when they are empty and you try to read from them instantly. And they will block when they are full and you try to write to them, because, well, if they are full, it's like a queue. Oh, it is actually a queue. What are these useful for? And how do you do that? Well, there are a few funny operators. Well, just one. If you want to write to a channel, you do it like that. If you want to just get anything from the channel and do nothing with it, you well, just get it. If you want to assign it to a variable, that's pretty straightforward. And this might be surprising because, well, what am I doing in here? Am I getting two things out of a channel? Why is it called OK? Well, in Go, there are no exceptions. So Go doesn't use exceptions. You don't have to catch things, but you will get error codes or you'll get status variables. And it's a pretty commonly used language idiom. So this actually says, this will assign to a variable, and it will be set to true if the channel has not been closed. So what do we make out of it? Well, that's a basic program that creates a channel, and you can have a goroutine that writes something to it, and then you can have another one that receives. Pretty straightforward. In its bare form, it doesn't really see amazing, but remember, this can run on different threads, and as I said, Go runtime provides the synchronization primitives that you would need, so it will work correctly. That's the assumption and that's the guarantee that is made by the runtime. And if you have been writing as well multi-threaded programs by hand, you know what a pain it is. Do you like it? I've heard a yes. Do you like Go, or do you like writing multi-threaded things by hand? Multi-threaded things by hand. Well, it's an interesting experience, but I try not to. I try to have, well, yeah, as somebody said, it's nice when you do it once, but then when you have to debug, I guess, well, all the fun goes away. So yeah, we've seen basic channels. So far, well, yeah, they have basic synchronization primitives built in, yeah, nothing amazing. So the real power of channels shows when you want to coordinate goroutines with them. So there is a construct that I try to demonstrate in here. You can make a channel and then close the channel, and in the very beginning, well, or put anything to it, and then in another goroutine, try to get anything. Well, try to take anything out of this channel. So what will happen in here? Because this is probably pretty confusing. As you can see, there is one goroutine that actually runs another. It's an anonymous goroutine being created, well, defined in here. And this construct, either, well, this or this, means that this guy will block until this gets executed. So you can have, of course, code somewhere in here. And this means that you can coordinate multiple routines, so effectively have a multi-threaded program running in some ordered way. And that's a pretty common way to do things. You have a control channel that you don't really write anything into. You just close it when one of the goroutines needs to signal another to close or to start work. So if you'd like to do something like a latch or a countdown latch, or, well, whatever you would call it, if you've been to horse races, or if you have seen horse races, you know the barriers that happen when the horse race is due to begin. All the horses enter, and then when it all opens, everybody goes. Well, this is the same primitive explored, well, in here. So that's the channel defined. You launch the worker, but obviously it blocks at the very first line. And then, when all the workers have been created, all the things have well, been initialized, you can close the latch, which means this line will be passed and all the work will begin at the same time, which is pretty useful, pretty neat. I think it's pretty, well, I think it's amazing because it's what, 7 lines of code, including the func? Do you like it? Good. Well, I like it a lot. I use it a lot. I find it extremely useful. And another cool thing about channels that you can use them as generators. Generators, well, if you know database sequences, you need, well, then you know what I'm talking about. If you need, well, some primitive that will generate a value only once, you can use channels for this. This is exactly what you would do in here. So you define a channel, you define a function that has a counter inside, and there is a funny for that says, write this counter to the channel, and then increment the counter. And somebody might say that, well, if we run a function and we keep writing in a for and that doesn't seem to have any bounds, it will run forever. Because, well, why would it not? Because it looks like an infinite for. Luckily it doesn't. It only happens each time that you actually need the variable. But don't trust me. Let's see how it works. So you can see that, well, something is saying generated and something is saying iteration, something value something. If we take a brief look at the code, well, first of all, there is nothing fancy in here. But you can see that the generated comes from the block that gets executed in the for. And that's an awesome thing, that's an awesome, well, language construct that you can actually execute a block of code and block until it's needed. That's what I really like about Go. It's very smart and very succinct, and it works the way you would like it to work. So I use this quite a lot, and to me that's a very useful feature. Yeah. So move on. And you can of course use multiple channels at once, because why would you not if you can use one and they are already thread safe? So you can do something like this. You can see a select in here. And yeah, I haven't told you anything about the select. And what this construct in Go means that this program will execute one of the three things. If there is something coming from channel, well, you could put code in here that would execute. Same for this one. Same for this one, if you actually produce a value and put it into the output. And as a default, there is nothing. And how Go will execute this block is whenever one of those three actions is possible to be executed, it will. If there is nothing possible, it will just wait until it is. And you don't have to do fancy manual, well, checks, ifs, nest, well, whatever construct you would think that would be needed there. You just write a select, then declare your operations, and then you're done. To me, that's amazing, again, and I love this construct. It's very useful when you're trying to do something multi-threaded. It saves a lot of time, and it makes control structures really, really explicit. Ranges. Because we can have a range in a channel. So if you want to iterate over a channel, you can. That's one of the uses of the keyword range. And this will actually get all the values in a channel. I'm using an unbounded channel here, so I could put as many things as I want. And if I didn't close it, I could actually leave it running. So without the close, this for would keep printing new values whenever they are put in. So imagine listening on a network socket, or being a server or trying to, well, copy some traffic from one place to the other, this is exactly the construct that you would need to use. And it wouldn't grow much bigger because you just need a proper socket, copy a bit of I/O from one place to the other, and it's done. Packages. As I said, go compile a package at a time. But how do you organize your software? What do you do there? Well, if you have a sample Go project, this is, well, the whole package structure. There is a bin directory which gives you the binaries, so things that you can execute. It gives you packages, which look like this. And in an SRC contains sources. This is the parent directory of each package. So there is a main. And the main package is, well, the package that is expected to contain to contain the executable, so something that contains a main func. And all other packages will end up as something that you can import or export, but they will not produce executables. And there is an awesome thing about packages in Go. Again, because I told you that it performs a bit like Maven. And what I meant is, well, let's take a brief look at the code. You can probably see that I import a package that says code.google.com/p/ well, whatever, which means that this package, as you expect, will come from the internet. And how would you fetch it into your well, project? That's quite easy. You would do, well, go get. It ran really quickly because I already did that before, so my computer already has the package. So if I do tree, whatever. So if we go into packages, we can see the code Google thing. And if we go, well, let's go somewhere else maybe. Let's go here. So what GoGet did is it downloaded the sources. So in here, you get all the sources for the package that you wanted to use. So it's done. One command built into the language. Forget Maven, forget Ruby gems, forget dependency hell. It's already handled, and it runs, and it works pretty neatly, and it actually, well, saves you a lot of trouble. Let's see. Well, oh, it doesn't run because something. Because I'm in a wrong directory, of course. So let's look a bit at the code. So what this code does is, well, creates a handler that will have a WebSocket handler that will listen on the, well, localhost 1984. And a handler is a function, so you pass a goroutine, or you can create a handler around the goroutine, which means a handler will just execute each time something comes. So will it actually work? Well, it's not WebSocket, of course, because, well, Chrome doesn't do WebSockets like this. But as you can see, well, something happens. So this is how much you need to do something that listens on a WebSocket. If I would have a WebSocket, I could, send it something and then do a basic hello world over WebSocket. In, what is it, 16 lines? That's pretty neat. And I didn't have to look for a lot of dependencies, download packages, extract zip files. It's all baked into the language. You just have to find, the proper package. Yes, unfortunately, and it wasn't in the default runtime, but then that's all you need. Of course, if you need more logic there, the code would grow, but I find it really short and expressive. So let's move on. The import we have already discussed. So if you want to use other packages from, the internet, if you have an internet connection, it's easy. If you have your own Go package repository, that's pretty straightforward. It's straightforward what to do. And then after you download the package to your project directory, you don't have to go to the internet each time to, like Maven does, for example, for things, which is, saves you a lot of time, works nicely, and allows you to develop things faster. So GoGet, we discussed. Net, we took a brief look at it, so let's take a look at something else. if I would like to do something that works on, well, works basically as an echo server, there is not a lot I would need to do. So this is what listens on a port and just, well, basically copies things from the input to the output. So you can I told you that Go doesn't have exceptions. So you can see that accept call to accept returns two things. Well, the connection or an error. So you have to check the error, and then if it's not nil, then well, something went wrong, and the error will contain the instructions about information about what actually went wrong. But if all went fine, error is nil, you're saved. There is no exception, well, exploding your application, which means that you can, well, you can basically keep running. Let's stop this. Let's restart. Yeah, it works. So, but there is a trick to this, of course. If I would like to do it from two panes at once, I will get nothing. The funny question is, why do I get nothing? And the reality is because if you look at this, it's, well, it's not obvious, but it's because it's single-threaded. Because to make it concurrent, there is one thing that's needed. So I don't think you noticed, so let me help. Is it awesome? I find it awesome. I loved it. I love goroutines. I use them a lot, and I find them really, really useful. It's very simple to do concurrent programs, to do multi-threaded servers, do things with your traffic with just, well, a simple code like this. And this is not a lot of code, and it well, just takes things from a connection and puts it in, well, replies, but nothing stops you from writing more code there. WebSockets we've already seen. So yeah, you can do WebSockets, you can do things. So what looks bad? First thing that looks bad, well, that's the worst thing. If you need to do JSON manipulation, sorry, this will hurt your eyes. But, well, I hate it. Sometimes, well, a lot of config files that I parse happen to happen in JSON. I don't like it. Another thing that sometimes hurts productivity is, you've seen the package, Go will complain whether you have a package declared that you don't use. Same happens for variables. So you have to be careful not to put extra code in there. So you might end up commenting a bit more code than you normally would. But then, still, the amount of code that you have to create is pretty small, and you get awesome results. So web server in 16 lines, yes, you can somebody could say that you can do it in, well, some language in one line, and you can probably make the Go version much smaller, but it's actually quite useful, and it already handles some errors. And then if the code grows, it doesn't have huge growth potential in terms of lines, so you will find it easy and quick to read it, and to fix bugs if they happen, because, well, you know how software works. So I hope you liked my ideas about Go, and I hope you understand why I like Go in general. I hope that you do go to the Go language's website and try it out. Try to write a few simple libraries. Well, try to do a hello world. Try to do an HTTP server. If you have any questions, we can do it over lunch, or we can do it later. I'll be around. And, well, thank you guys for attention.
Thank you very much.